Alright, so you have a big sheet out now that's got all the notes on it. Each problem is going to be a slide, so we've got 3 slides that we got to get to. Unfortunately, I couldn't fit all of the second problem on one side. Didn't give me enough space to show you work, so the part C is on the top of the back side for number 2. Okay? Alright, so question or word problem numero uno. Mrs. Hoff searches the couches in her home for loose change and collects it. One year, she collected $207 in change from her couch. She puts this money into account for a rainy day, exactly, that pays 4% interest that is compounded monthly. Question A. Write a model to represent the money in her account. Well, first off, we're going to have the compound formula. And the compounding formula is P equals A times 1 plus R divided by N to the NT power. P is the amount. A is your starting value. 1 is the number that comes before 2. R is your interest rate, or the rate of change. N is the number of times that it's compounded. And T is the time, and T for this problem is in years. So we need to write a model that represents, yes ma'am?
So, like, for this, since it's like compounded monthly, it's by years, would it be 1 or would it be 1?
Well, how many months are in a year? 12. So N would be 12.
Well, I didn't
Yep. 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 So write a model to represent the money in her account. Well, that's going to be P. Well, actually, let's figure out what we all have. So P is going to be the amount of money. It's kind of what we're looking for. A is going to be the amount she started with. So how much money did she start with? 207. R is going to be our interest rate. Our interest rate, 4%. So in terms of a decimal, what would 4% be? 0.04. N is going to be the number of times that it's compounded for the year. So if we're compounded monthly, N would be 12. And T is going to be the time, or the number of years. So that's just going to stay T. That one we can't change. Okay? So, putting that all together, we could go P here equals 207 times 1 plus 0.04 divided by 12 to the 12T power. I would prefer it just left like that.
I'm talking about like
We'll get there, because it all depends on what we have. You know what I mean?
Yeah.
In this case, we're talking money, so we'd go to 2 decimal places, because that's the pennies. If we were talking people, we would go to a whole number, because you can't count half a person. Okay? You know, it all depends on the situation that you're dealing with in that particular problem. Okay? So, based upon that formula now, how much money will be in the account after 5 years, assuming that it doesn't rain, because this is her rainy day fund. Okay? So that's going to be P is what we're going to be looking for. 207 times 1 plus 0.04 divided by 12 to the 12 times 5 power. So we would need to get an old calculator. Now, depending upon how you want to, with parentheses, if your calculator is able to see parentheses, with parentheses, you could type it in basically as is, provided you put some parentheses around some things. If you can't, you can always do it the old school way. You start on the inside of what you have. So I would start with 0.04, and I would divide that by 12. And I get that. Then I would add 1 to that. Then I would take that, in my brain, I'm like, well, 12 times 5, that's 60. So I would take that to the 60th power. And then I would multiply that by 207. Now that is going to give me 252.74629 as a number, but because this is money, what would we round that to?
The 4 has to go up to 5.
So what would we round it to? $252.75. Yep. Questions on that? Slide out too so you can see it. You find me how much money is in the account after 15 years. I didn't see it. Well, I am, but that's all right. Oh, is that enough? Well, you've got the cheese. Ooh, that's a bad 8. Come on, Linsmeyer, you're better than that. I get $376.80. Yes? No? Maybe. I did 0.4 divided by 12 equals plus 1 equals to the open parentheses 12 times 15 close parentheses power equals times 207. Now on this one, on your calculator, you could go 207 open parentheses 1 plus open parentheses 0.04 divided by 12 close parentheses raised to the open parentheses 12 times 15.
Okay. Thank you.
Good? Everybody got that? Okay. Question D. How long until the account will have $1,000 in it? Now, we're going to have 1,000 is going to be my P. 207 times 1 plus 0.04 divided by 12 to the 12t power. I've got to solve that. How am I going to solve that problem?
Solve for T.
How?
Switch it.
Can't switch it.
Square root it.
Can't square root it.
Yeah. Or can you use that?
No, we can do it. What you got, Jess? You were going to say divide by 207?
I was.
Right?
I was.
Yeah, I like dividing by 207 first. Why do I have to divide by 207 first?
Yes.
I got to get my exponented term isolated, right? Okay. So, if I divide both sides by 207, oops, went a little too far on the second. If I divide both sides by 207, I get 1,000 divided by 207 equals 1 plus 0.04 divided by 12 to the 12t power. Now I can switch forms because now I got it isolated. So it would be what? When I switch it.
Log 12T.
No.
Log of.
Log of 1 plus
Log. We need a base first.
log is 1 plus 0.04 divided by 12.
Of
1,000 divided by 207 equals 12t.
how am I going to figure out the left side of this equation? Can't put it in the calculator. It's not log base 10 or log base e.
Log base 100 of 100 divided by 207, and you divide that by log base 1 plus 0.04 divided by.
I think what you're saying is this. It's not what's coming out of your mouth, but I think you're saying I want to take the log of 1,000 divided by 207 and divide that by the log of 1 plus 0.04 divided by 12. I think that's what you were trying to say. Or take the natural log of this. What is this that I'm doing? What was that? The change of base formula? Yep. Yep. Okay. So what do we get here on the left side? Anybody want to take a shot? Guess?
400
I got. Yes? Yeah? Now what? Now divide that by 12.
And then for this one, would you want a whole number?
What did we just find?
The year.
How many years to get to $1,000, right? Would I need a whole number? No, because we have partial years, right? Yep. So I get 39 point, we'll call it 442 years. Agree? So she puts that $207 into her account. Account pays 4% interest. In almost 39 and a half years, she's got $1,000. By doing nothing. I mean, not just by doing nothing. So. Okay. Questions, comments, concerns, clarifications? Fantastic. Number 2, the amount of toxic fumes measured in Stanky units, or SUs, left in the family truckster after the road trip to Florida can be modeled by the formula F of H equals 2,000 times 0.87 to the H power, where H is the number of hours after we got home. Stanky units. Never heard of them?
No.
Probably because you're not used to being said just stanky units. You need to say it stanky units. Okay? So, my question to you is, as soon as we pull, bless you! You didn't get any chicken on the inside of your shirt, did you?
I don't know. I think I saw what's that.
Okay, that's good. That's good. Yeah. Question A. How many fumes were there in the van, in the family truckster, the moment we got home? Okay. How much? 2,000. How would I figure out the moment we get home, what time, how many hours have we been home? 0, right? Okay, so I'm basically finding what this question is finding is F of 0. The starting value, 2,000 times 0.87 to the 0 power. Anything to the 0 power is 1. 1 times 2,000 is 2,000. So there's 2,000 stanky units of fumes in the van the moment we got home. Okay? B. How many stanky units of smell are left in the van 24 hours? So the next day. So we're finding F of 24. Okay. Anyone? What you got, Jazz? So we'll call that 70.712. Must be contagious.
I was literally thinking the same thing you were doing.
Yes? Okay. Question C. If the human nose can't detect a smell with an SU value of lower than 7.8, when will the van return to its normal smell?
So,
So we still have the exponent still would be H, but it would equal 7.8 instead, and then
So the equation is going to be 7.8
equals 2,000 times 0.087, or 0.87 to the H power.
H power. Is that what you were going to say, Sid?
yeah.
Yep. Okay. So how do we go about solving said equation? Divide by 2,000. Then what? Change forms, right? Change it to a log form. What do you got, Ellie?
Log 0.87. Is it 2 then? How would you say
Of.
Of 7.8 divided by 2,000 equals H.
Okay. Now, before we even calculate this, approximate what value it should be. Based off of letter B. What do you got? Should it be 23? Why not?
Because 24 hours it's still.
At 24 hours, we just found that it was still at 70. We got to get to 7.8. We're coming down from 2,000.
200.
Okay? So it's got to be more than 24. So if I get something smaller than 24, we just found that we did something wrong. Okay? So that's one little check. So now let's figure it out. $39.83. Yes? Questions, comments, concerns? Try number 3. You can tell me because she can't pull her phone out. So the hate that she had directed at me is now directed at you.
Don't worry. I understand.
Alright, so when a plant or animal dies, it stops acquiring carbon-14 from the atmosphere. Carbon-14 decays over time with a half-life of about 5,730 years. Note, this means it takes 5,730 years to lose half of its carbon-14. The percent P of the original amount of carbon-14 that remains in a sample after T years is given by this equation. Love it. What percent of the original carbon-14 remains in the sample after 5,730 years?
I just have a question.
What's up?
So it said, because it's in every 5,730 years would be half, so that.
Percent, right?
But you have to write all that out. That was still like all the work.
Well, what would the work be?
Well, it would just be all that power.
Right. Yeah. So it would be P equals. For this one, you wouldn't have to, because if you're smart enough to realize that I'm giving you the answer in the problem. So that means that there is 50% left. Okay? Now, the problem though with that is for this next one, for part B, now we have to write it out because now it's not, doesn't work out so nice and pretty. Yeah, no, that's nice. So P here now is going to equal 100 times 1/2 to the 2,000 over 5,370 power. Now, logic tells me, should this be more or less than 50%? Why more? It's less than the half-life, right? I'm still inside of one half-life. Okay? Haven't gotten to the full half-life yet. So, then, this, now I gotta go over her, and I gotta go on, and I gotta go 2,000 divided by 5730, and then I'm gonna take 0.5, raised to that power, and then I'm gonna multiply that by 100, and I get 78.510627.6. So I would say that that is 78.511%. Because we've been kind of rounding everything to 3 decimal places. Yes? No? Didn't get that. Good? And it still doesn't come up. Let me see what you typed in. So you would type in 100. 1/2 to the, and you did the 2,000 divided by 5730 right before that? Yep. Okay. So then now go down one. Now we'll let you do that. There you go. Oh, because you did 1,000 instead of 100. That's why. Oh, shit. Yep, you get one extra zero in there. You might multiply by an extra factor of 10. Okay? What percent of the original copper-14 remains after 20,000 years? So that would be, whoa. So that would be P equals 100 times 1/2 to the 20,000 over 5730 on 20,000 divided by 5730, 0.5 raised to that power, and then times 100, and I get 8.89783,763, or 8.898%. Yes? Love it. When will the sample have 1% of the original carbon-14 remaining? Well, now that's going to be 1 equals 100 times 1/2 to the T divided by 5730. First, divide by 100. Then, log of
1/2
base 1/2 of
100
equals
divided by 5,730.
I get 6.643856619 equals T over that. In the end, I get 38,069.296 years. Yes? Homework sheet for today is going to be salmon. 3 questions.
Why wouldn't you do 64% and 0?
Because it gave us P as the percent in the original problem. P was the percent.
What?